Hi, good morning. This lesson is lesson 18 on surface area of a cube. So let's write a formula to find the surface area of a cube. So that is our learning target. 18.1, we're going to do a quick exponent review. So we're going to select the greater expression of each pair without calculating the value of each expression. Be prepared to explain your choices. So 10 times 3 or 10 times 10 times 10. So if you did 10 times 3 versus 10 times 10 times 10, which one do you automatically know is going to give you the bigger value? 10 to the third power. So this guy right here. All right, 13 squared or 12 times 12. Well, 13 squared really means 13 times 13 versus 12 times 12. Well, 13 is bigger than 12, so therefore the 13 squared is going to give you more. 97 plus itself 5 times, so 1, 2, 3, 4, 5. Oh, wait, 1, 2, 3, 4, 5, 6 times, sorry. So 97, but instead of adding 6 times, we can just multiply times 6. Or 97 times 5, well, there's more 97s here, so this expression will give you more as your answer. All right, 18.2. The net of a cube. A cube has an edge length of 5. Draw a net for this cube and label its sides. I'm going to draw just the basic net for a cube. So usually what I do is I just draw a large rectangle. I cut it in half and I cut it in half again. These kind of look like sorry, these aren't very cube-like, but we'll just pretend that they're all the same. And then we'll label them all 5. So this is 5, this is 5, and this is also 5 right here. So there's my cube. I'm going to show you all the different ways we could have drawn the cubes. So here's all the different ways you could have actually drawn the net of a cube. So if you have any of those, that actually works as well. So you can draw any of those. I just typically go with the T looking one. So the shape of the face of each face is a square. The area of each face, well, if they're all 5 times 5, that will give us 25 inches squared. The surface area, well, if each of them is 25, what I could do is I could do 25 plus 25 plus 25 plus 25 plus 25 plus 25, or I can do 25 times 6. And that gives me 150 inches squared. The volume, well, if we were to make it into a polyhedra instead of its net, it would be 5 times 5 times 5, which gives me a volume of 125 inches cubed. All right, now what I want you to do is go ahead and do the second one. So pause the video, draw your net for your cube, label it with 17, and then go ahead and give an answer for each of those. So pause your video and take care of that, please. All right, here are the answers for number 2. So here's my net, and I labeled my 2 sides here and then this length here. And then B said explain why the area of each face is 17 squared. That's because area is base times height, so 17 times 17, which gives me 17 squared. Write an expression for the surface area. So if one of the faces is 17 squared and I have 6 of them, I could just do 17 squared times 6. And then D, write an expression for the volume. Well, I know it's going to be 17 times 17 times 17 because my length, my width, my height. So 17 times 17 times 17, or 17 to the third power. All right, now we're going to move on to 18.3. Every cube in the world, a cube has an edge length of S. So any side length that we give a cube, we're going to come up with some rules there. So we're going to draw a net for a cube, then we're going to write an expression for the area of each face, label it, write an expression for the surface area, and then write an expression for the volume. So again, here's my net. We're going to give each face the letter S as its side length. We're going to write an expression for the area of each face. So this would be S times S, which is S squared. And then we're going to label it because that's what it says. Label each face with its area. Here, let's put the S right here at the bottom. And that's S squared. So we know that it's S times S, which is S squared. And then write an expression for the surface area. So now we're going to add S squared plus S squared plus. If you keep repeatedly adding, what you're really doing is multiplying. So 6 times S squared or 6S squared. Now we're going to write an expression for volume. So we know it's S times S times S or S to the third power. So this is your formula for volume. This is your formula for surface area for cubes. So you guys just came up with your own formulas by just going through these little lessons. All right, here's your lesson 18 summary. And I would go through and I would read these. Okay. And then you've got some practice problems here. So if you'll pause your video and then I will put the answer key up in just a moment. Now that you've had time to work out the problems on your own, I'm going to go ahead and write the answers in. So number 1 is 512 inches cubed. If I did 1/3 times itself, I get 1, so 1/3 times 1/3 times 1/3 is 1/27 centimeters cubed. And then a cube has a volume of 8 feet cubed. So what is its edge length? So what times what times what gives me 8? Well, we can go back into our notes because we did it in lesson 17, excuse me, where we wrote our perfect cubes. There it is right there. 2 times 2 times 2 is 8. So I know that X has to be 2. So my side length is 2 feet. All right, what three-dimensional figure can be assembled from this net? A cube. If each square has a side length of 61 centimeters, write an expression for the surface area and another for the volume. So you can do 61 squared because that's the area of one of the faces. And then because you have 6 of them, times 6. If you put the answer where you actually multiplied it, 61 times 61 times 6, you get a large number of 22,326 centimeters squared. So both of these answers are totally fine. Okay. And then the volume, so volume would be 61 times 61 times 61, which gives you 61 cubed, or, so this is one answer, or 61 raised to the third power gives me a very large number, 226,981 centimeters cubed. So both of those answers work just fine for that one. All right, number 3. So now we're going to draw a net, or here's a net of a rectangular prism that was not drawn accurately. Explain what is wrong with the net. So first of all, this side is supposed to match this side. So the side lengths are not the right sizes. And then draw a net that can be assembled into a rectangular prism. So this is just too big for this. So explain what was wrong. The sides don't match. Okay, draw a net that can be assembled into a rectangular prism. So if we move them, if we just moved it, I'm going to do it down here. If we moved it like this, so maybe put the square here, and then 2 of them like this, and then maybe a skinnier one here, and then the same size here, and then the same size here. Okay, So this was B, or number 4, so this is 4B. Create another net for the same prism. You could do a square like this, and then 2 rectangles this way, and then 2 rectangles this way. So this will still fold up into the same shape as this here. So again, this was 4B, or 4C. Okay, so these are boop, boop, down here. Oh, I skipped number 3, I'm sorry. Draw a net for a cube with an edge length of X. Oof. I do not do a good job drawing squares, do I? Okay, so X, X, and X. What is the surface area of this cube? Well, if this is X squared and there's 6 of them, it's 6X squared. And then what is the volume? It's X to the 3rd power. And then number 5, state whether each figure is a polyhedron and explain how you know, and that's going to be on the next slide. So A is no, because it has curved edges. And the 2 bases are not polygons. Figure B is yes. Because all faces are polygons. And this would be called a, let's see, 1, 2, 3, 4, 5, 6, 7, a septagonal prism. So, septagonal prism. Okay. All right, and number 6, here is Elena's work for finding the surface area of a rectangular prism that is 1 foot by 1 foot by 2 feet. She concluded that the surface area of the prism is 296. Do you agree with her conclusion? And then explain your answer. So, where her mistake is happening is she has 2 feet and 1 feet and 1 feet, but then she has 12 inches. So what she's doing is she's changing the type of units being used, and you can't have a mixture of them if you're going to add them together. So if you're going to stay feet, you need to stay feet up here. If you're going to change to all the inches, then you need to change to all the inches. So really what she should have done was kept these as 1 foot. And then she could have done her 2 by 1. But then there's front and back. And then her 2 by 1 here, which is her left and right. And then her top and bottom are 1 by 1, but she has 2 of those. So this gives you 4, 4, and 2, which then gives you 10 feet squared. Okay. So again, she just converted to inches when she should have just stayed feet. Now, if you want to convert all these to inches and go with an inches answer, that is fine as well. All right, that is it for this video. If you have any questions, you can ask tomorrow in class. I hope you guys have a great day, and I will see you later.